Alright everybody, so last video for today is on how to name ionic compounds. Remember that the naming is going to change once we move on to covalent compounds, but for now we're naming ionic compounds. Recall from the other videos that ionic compounds are made of a metal and a non-metal almost always, and the metal becomes the cation, so it's positive, and that's always listed first, and the non-metal becomes the anion, and that's listed second. So starting out with these examples, if you don't already, in addition to this video, you should have this pulled up in another tab. So if you don't have that done yet, take a second to do so that you can take a look at it as we're going. So the first thing we're going to do is make sure the compound is ionic. So all the examples today that I'm going to give you are going to be ionic compounds, but eventually they'll be mixed in with covalent compounds, and you need to make sure you're using the right rules. So the first thing you're going to do is make sure that you're talking about an ionic compound. Then we're going to write the element name of the cation or the metal exactly how it is. So if we look at our periodic table, we'll look at this one. For our first compound, which is LiCl, our cation or our metal is lithium, Li. So we're just going to start by writing lithium. Notice it's not capitalized. We don't capitalize the names of compounds. They're not proper nouns. Then if we go back to our flowchart, it says, does it have only one oxidation state? So oxidation states we find on this one. And lithium, you can see, just has an oxidation state of +1. It's not like, say, manganese, which has all this list of possible oxidation states. Lithium can only be +1. So we're going to say, yeah, it only has one oxidation state. Then it's asking if the compound is binary. Binary means it's made up of only two elements. And LiCl is just made up of lithium and chlorine. There are only two elements in that compound. If it were LiClO, that would be a different story. You'd be talking about something with three elements, and then it would not be binary. But yeah, this one's binary. So back here it says, is it binary? Yes. Now it says we're going to write the element name of the anion, replacing the ending with IDE. So instead of chlorine, which is what Cl is, we're going to write chloride. And so the name, and we'll look back at this, and that says rewrite it neatly if necessary, meaning like if you made it really sloppy to begin with, like if you were figuring stuff out, then rewrite it. But basically that means we're done. So this compound, LiCl, is lithium chloride. Go to the next one. So first thing we're doing is making sure it's ionic, which it is. Then we're going to write the element name of the cation or the metal. So pause the video right now and write the element name for your cation. Hopefully you wrote zinc. Go back to our flowchart. Does it have only one oxidation state? So we have to look here and find zinc. Zinc can only be +2. So it doesn't have a list like vanadium or chromium or manganese where there's multiple different states that it can take. Zinc can only have an oxidation state of +2. So, yep, it only has one oxidation state. Is the compound binary? Even though there are 3 atoms here, zinc and 2 chlorines, it's only made up of 2 elements. So if it's only made up of 2 elements, zinc and chlorine, then it is indeed binary. So then we go back here. If it is binary, write the element name of the anion, replacing the ending with IDE. So instead of zinc chlorine, we would write zinc chloride. All right, pause the video and try to name Na2S. Hopefully what you did was you looked at your flowchart. You said write the element name of the cation, so you wrote sodium. You figured out that sodium does indeed have only one oxidation state because sodium can only go to +1. And so you asked yourself, is this a binary compound? And you said, yep, it's only made up of sodium and sulfur. So yeah, it's a binary compound. And then you changed the ending of sulfur to sulfide. You'll get used to the where the ending goes as we keep practicing these, so you might have written sulfuride or something like that, but it should be sulfide. Okay, moving on to a couple more difficult examples now. So starting with NiO, we're going to look back at our flowchart. And these are ionic compounds. They're all made of metals and nonmetals, but remember when we have mixed examples, you need to check that. Write the element name of the cation or the metal, so that part is stayed exactly the same. So NiO, Ni, if we look over here, is nickel. So we're going to write nickel, nickel. And then the next thing our flowchart asks is does it have only one oxidation state? So if we find nickel on our periodic table, right over here, number 28, we see that nickel can either be +2 or +3. So that metal has more than one possible oxidation state. So no, it does not have only one oxidation state. Now it says determine the total charge of the anion. Remember, the anion is the nonmetal. It's the part that took the electrons. So if we look over here, our anion for this compound is oxygen. So we need to find the charge of oxygen before we move forward. Oxygen, we see here, has an oxidation state of -2. And since there's just one oxygen, it doesn't have a subscript after it, the charge of our anion is going to be -2. Now it says, figure out the charge of each atom in the cation by finding the total charge and dividing by the number of atoms. So what that's saying is that in order for this compound to be neutral, the charge of the anion has to be equal to the charge of the cation, or has to be balanced with the charge of the cation. So if our anion is -2, in order for it to be neutral, our cation has to be +2. Now, if I had multiple atoms here, if it was like Ni2 or Ni3, I would have to divide that charge up between all the atoms, but because there's just one, the division is pretty easy. It's a charge of 2 divided by 1, and that gives us 2. And our flowchart says, write that number, the oxidation state, in Roman numerals in parentheses. So we're going to do that. So it's going to be nickel 2. And what that means is that of all these options for nickel, where it could be either +2 or +3, that's telling us that we're talking about the type of nickel that is +2. We're talking about nickel having lost 2 electrons. So we're talking about nickel 2. That's how we say that. And then if we look back at our flowchart after we've written that oxidation state, we're going to say, is the compound binary? And this is just nickel and oxygen, so yep, it's binary because it's only 2 elements. Now, write the element name of the anion, replacing the ending with IDE. So instead of oxygen, write yours down. Hopefully you wrote oxide. All right, moving on to our next one. Oh, and if we were going to say this out loud, we would say nickel 2 oxide. And we have to say it that way because nickel can be +3, and then it would be nickel 3 oxide. And that's a different compound with different properties than the one that we have there. All right, so our next one is Au2F2. So just like always, we're going to write the name of our cation. In this case, it's Au, which is gold. So we're going to write gold. Then it says, does it have only one oxidation state? We find gold down number 79 in our periodic table, and no, it doesn't. It can either be +1 or +3. So that means we have to follow this part of the flowchart that says we have to determine the total charge of the anion. Our anion here is F2. So that means that we have to figure out the charge of this entire thing. We know from our periodic table that F is going to have a -1 oxidation state. So each fluorine is going to take 1 electron. Each fluorine is going to be -1. So that means that if we have 2 of them, the total charge for this whole thing is going to be -2. -2. And just like above where we said we had to balance it out and make it neutral, we're going to make our cation, I'll circle that in purple here. Our cation, the whole thing together, has to be +2. However, because there are 2 gold atoms here, it's Au2, not just Au, we're going to divide this charge up between both of them. So it's going to be 2 divided by 2, which is 1. So it's gold 1. Oh, that's the wrong color, sorry. Gold 1. And that's what we just did here. We figured out the charge. We figured out that this is the type of gold that's going to have a charge of +1, and as opposed to the type of gold that has a charge of +3. So it's gold 1, and then We go back here, is the compound binary? Yes, it is. And we're going to replace, and write the name of the element for the anion, replacing the ending with IDE. So instead of fluorine, we're going to write fluoride. Last one, try naming it by yourself. Pause the video. What you should have done is written the name of your cation, which CO is cobalt. Then you should have seen that cobalt has multiple oxidation states. Cobalt can be +2 or +3. So you need to find the total charge of your anion. We know that oxygen has a oxidation state of -2. And because we have 3 of them, it's going to be -2 times 3. So we have -6. And then the charge of your cation, the total charge of this entire thing, has to be +6. And that +6 is divided up between the 2 cobalts. It's divided up between the 2 of them. So the number that we're going to write in Roman numerals is going to be 3. So it's cobalt 3, meaning it's the type of cobalt that has a charge of +3. This cobalt has lost 3 electrons. Then we're going to find out, is it binary? Yes, it is. And write the anion replacing the ending with IDE. So instead of oxygen, you would write oxide. Alright, here's our last set, and you should notice something is different right away. We're no longer dealing with binary compounds. All of the compounds that are up here have more than 2 elements, so when it asks, is it a binary compound, now we're going to answer no. So just like always, we're going to write the name of our cation. I'm just going to do all of them because we've done that a lot of times. So for the first one, it's magnesium. Down here, it's copper. And here it's zinc. Alright, so for this first one, MgCrO4, first thing we're going to look at is, we already wrote the name of the cation. We're going to ask, does it have only 1 oxidation state? Magnesium does indeed have only 1 oxidation state, so then we're going to say, yep, is the compound binary? And we already discussed that no, it is not. So now we need to look at what's called our polyatomic ion chart to find the name of our anion. So our anion here is CrO4. And we're literally just going to look at the chart and take the name. So here's our polyatomic anions. Ooh, sorry. And we're going to take chromate, which is the one that's CrO4. And it has this -2 that tells us that its oxidation state is -2. So this one is magnesium chromate. Using the polyatomic ion chart is pretty easy. You're just taking the name from there. You just have to remember that that's what you use when you have non-binary compounds. Here we have CuSO4. We already wrote copper. Does it have only 1 oxidation state? So looking back down here, copper does not have only 1 oxidation state. So that means, like before, we have to find the charge of our anion to figure out the charge of our cation. So our anion here is everything after copper. It's SO4. And so I'm going to look for SO4 on the polyatomic ion chart. SO4 is right here. It's sulfate. And sulfate's charge is -2. So above it, I'm going to write -2. That means that my cation, my copper, wrong color, this has to be +2. And there's only 1 atom here, so there's nothing to divide it up between. So I don't have to do any funny business there. I'm just going to write copper 2, meaning that this is the form of copper that is going to have, it's going to be +2. Is the compound binary? Nope. We're going to look at our polyatomic ion chart up here, and we already said that it is sulfate, right? Not sulfite, sulfate, because it's SO4. So we're going to write copper 2 sulfate. Last one, ZnCN. So we already wrote zinc. Looking at our periodic table, zinc only has 1 oxidation state. Cool. It is, so we don't need a Roman numeral. It is not binary, so we need our polyatomic ion chart. And Cn is cyanide. So our name is zinc cyanide. Alright, that's the last video. Hope it helps. Plan on staying after school tomorrow if you are still confused. Bye.